Okay, we are finally ready for the good stuff. Now remember, the purpose is to somehow measure the sensitivity of bond values to interest rate changes. So we don't want to recalculate the value of the bond each time that interest rates change. And interest rates change repeatedly during any given day, especially if you are a portfolio manager holding a variety of bond securities within your portfolio, or any other security for that matter. Each of these components will have a different value on a continuous basis, continuously throughout the day, and each time you would have to reevaluate each of the constituent security values and then aggregate them to find the portfolio value. It will be too bashy. So instead, what we're proposing here is somehow if we can find a way to measure the sensitivity, or elasticity, if you want, the elasticity of a bond. So it would, what type of sensitivity? Interest rate sensitivity of a bond. So then suddenly we can approximate up to a certain error term that's given to us, we can approximate the value of the bond actually. So it's a really, really useful method. And the whole idea is based on Taylor series approximation, Taylor approximation, which is a topic that we learned during the first week when we started looking into the foundations of calculus. All right, so first let me describe what duration means. So in the technical sense, duration is the definition, if you want. So let me say definition. So the definition is the following. It's just a weighted average, time to maturity, basically. Time to maturity, that's it. That would be a simple definition. So weighted average, but what are the weights? So the next question is, what are the weights? What are the weights? It turns out that the weights are just the cash flows during those periods. What are the weights? Answer, cash flows. So that's very interesting. So here what we are doing in a sense is to try to figure out when a bond will expire in average. So time to maturity, right? So when will a bond expire? And it's a weighted average, obviously, and the weights are these cash flows. So let's just go ahead and work on an example how to make this calculation. It turns out to be a very simple idea, obviously. So let's and our way of approximating the elasticity, the sensitivity of the bond to interest rate changes will depend on that term called duration, on this concept. So that's a very important concept that we want to really make sense and investigate closely. All right, so consider the following bond. Again, bond security. So the bond is, let's say it's a 4-year bond, 4-year bond. It pays, actually, you know what, let's just number of periods. This is 4 years. Or let me write the question in English first, and then we can decide which variable is what. Okay, so let's finish it. 4-year bond, which pays, let's say it pays 10% coupon, with 10% coupon rate paid semi-annually. Semi-annually means every 6 months. So the whole annual amount will be divided into 2, and it will be paid in 2 installments every 6 months. All right, and the face value, say the face value is, again, is $1,000. That has been our tradition so far. And let's say that the discount rate, the required rate of return of a potential investor, required rate of return, required RR, let's just write it shorthand. Let's say that the required rate of return is, let's start with a simple example where it is 8%. But we know that that required rate of return, because coupons are paid semi-annually, we need to find a way to let interest accumulate every 6 months, so which will be basically halving this number. All right, so actually let me just go ahead and connect it here. So based on these givens, I think we can easily write down the variables. So the rate is obviously, okay, so because everything is semi-annual, we decided that, so the rates will be divided into two, 8% divided by 2, that makes sense, 4% basically. The number of periods, so how many 6 months are there in 4 years? Because it's a 4-year bond, in total there will be 4 times 2. Does that make sense? Equals to 4 times 2, which is 8 6-month periods. So the next one will be the face value. Face value is not gonna change. It will be $1,000. And the coupon payments. Coupons. Well, the coupons will be equal to the coupon rate, which is 10%. Let's write it. So 10% times the, 0.10 times the face value, which is $1,000. However, I need to divide by 2 again because we are paying those installments we are making these coupon payments in 2 installments. 10% of $1,000 is $100, but that $100 in coupons will be paid every 6 months. All right, so based on these givens, we can easily calculate the value of this bond as equal to, using that present value function. So the rate, comma, the number of periods, comma, the payments, this number, comma, and finally the face value. That's it. So the bond should have a value of $1,067.33. Perfect. Now I wanted to make sure that we are on the same page here, that we are speaking the same language. Let me highlight it. Now let's go ahead and do the duration calculation. Like we said, it is just the weighted average time to maturity. So because time is so central, let's put time on the first column. I'm going to construct a table at this stage, right? So time here, the cash flows next to it at each time. And next we will have a discount factor, and what else? And I will, and then I need discounted cash flow, obviously, and finally the product of discounted cash flow and time times discounted cash flow. So what are the times? So I will be receiving over the next 4 years, every 6 months, I will be receiving coupon payments of $50 each. So because it's every 6 months, half a year. Okay, so first let's make sure the formatting is correct. Okay, so I want to write everything in text, so let me just first format the cells, otherwise it's going, well, actually, you know what, I need to make them into a number. So let's just make it a number just to be on the safe page. Okay, there we go. All right, and I don't need that much decimal place. Perfect. So half a year, right? So half a year, 1.5 years later, another payment, 2 years, 2.5, 3 years, 3.5, and 4 years. So I'm expected every 6 months to receive, like we said, $50 in coupons. So let me just write down those 50s all the way till the last year, except during the last year, we know that we will also receive back the face value of the bond, so $1,050. So now we can go ahead and discount it. First, let's write down, we can do it separately or together. I think separately, sometimes students prefer that. So the discount factor will be the following: 1 divided by, open parenthesis, so the interest rate is 1 plus. So we are told that the required rate of return is, the rate is 4%, right? It's half of the full annual, which is 8%, right? So this raised to the power so the time period is the 6 months, right? So that's considered as a 1. So therefore, rather than taking directly to the power, open parenthesis, 2 times that number, all right? So which is 1 period. So each of the 1 period, 2 period, 3 periods, and so on. All right, that's pretty much it. So press enter, there you go. So I can just go ahead and drag this. Obviously it will, yes, it messed up again. I forgot to put the dollar signs as usual. So B14, that one needs dollar signs. So let me put that. And the rest can just float, right? So that's what I needed. So, okay, so let's double click one more time to see. Yes, the formula now is fixed. So I'm not sure if it's fixed as I wanted. Let me check. Yes. Oh, we need one more. Sorry. Let's do one more. There you go. Okay, so we're in good shape. The discounted cash flows will be just the product of this, the cash flow times the discount factor. Press enter and then double click this one too. Perfect. And lastly, because it's a weighted average, so we need to multiply the time column with that discounted cash flow column. That's it. So double click this one. Awesome. So at that step, I want to make two observations. The first observation is the following: value. So interestingly, if I simply add up these discounted cash flows, this is exactly the technique that we applied in the previous video, right, to value securities. That should give me 1067. And it's perfect, because if those two numbers don't match, then it already tells me I made an error, right? So this is equal to the sum. All right, so if I were to add up all these numbers, thanks God, so it is the same number, right? So if we want, we can just round it a little bit. There you go. So it's now exactly the same. Now, for the duration, I will do the following. Let me just change this to sum, so which is perfect. I need to also take the sum of these, right? So this is equal to sum. So taking the sum of these as well, press enter. Now the duration turns out to have the following very interesting formula. It is just equal to this number divided by the weight, which is this. So that gives us the time, the average time to maturity, weighted average time to maturity, I should say. Now, be aware that this is a 4-year bond, so the maturity is actually 4 years. But weighted average time to maturity gives you an idea about, in average, how long it will take you to recover your payments. You can't just say 4 years. In 4 years, you're gonna get the whole payment. But the average is 3.4 years. What it means is, because ahead of time, like in 6 months later, a year later, 1.5 years later, and so on, you are already started to be paid back, right? It's not like you're waiting until the last day to receive back the whole investment. That's not true. So because of that, so the duration formula basically takes this into consideration. That's it. So this is the duration, the way to calculate the duration formula. Hopefully this table approach should be a useful approach in valuing, not only checking your work to see if the valuation works, but also to calculate the duration. And like we said, the duration was calculated as dividing the sum of this column by this column. So in the next video, we are going to show how this duration number will help us with establishing the sensitivity of the bond value to interest rate changes.